All right, as promised, one more example, finding a sign chart, determining increasing, decreasing, and local mins and maxes. All right, so the function we're going to do this for in this example is 3 times x to the 2/3 minus x. Okay, so again, our goal is to make a sign chart over here, a number line where we're going to mark our critical points. We're going to find out if f prime of x is positive or negative in each region of the number line, and then determine whether that tells us f of x is increasing or decreasing. Okay, so let's find our critical points first. So critical points are where the derivative is equal to 0 or undefined. So let's find our derivative. So the 3 will go along for the ride. Bring down the 2/3, and then 2/3 minus 1 will give us negative 1/3, and the derivative of negative x is negative 1. So simplifying a little bit, those 3's can cancel out. So I've got 2x to the negative 1/3. I'm going to bring that x to the negative 1/3 down with a positive 1/3 exponent. And then I'm going to remember that that 1/3 exponent really means that I've got the cube root of x down here. All right, so remember that critical points are where the derivative is equal to 0, and we're going to figure that out in a minute, but they can also happen where the derivative is undefined. And the derivative is undefined at x equals 0. If I plug in 0, I'm going to end up dividing by 0. All right, so f prime of 0 is undefined or doesn't exist. So x equals 0 is a critical point. So I'm going to mark 0 on my number line. Then I also need to worry about, or figure out where this derivative is equal to 0. Okay, so I'm going to add 1 to both sides. I'm going to multiply both sides by the cube root of x, so that I get that cube root of x out of the denominator. So I get 2 equals the cube root of x. And then I'll just cube both sides. And I get the cube root and the cube to cancel. That gives me x equals 8. Okay, so that's my other critical point. So I'm going to come over to my number line and mark 8. Those are my 2 critical points. Okay, so then I'm going to take any test point I want out of those 3 regions. 1 over here on the left, 1 in the middle, and 1 off to the right. Okay, so I'm going to find f prime of, let's start on the left, I'll pick negative 1. Oops. Okay, so I'm going to use this version of f prime where it's all simplified. So 2 over the cube root of, plug in negative 1. And then, let's see, so cube root of negative 1 is negative 1, so this is negative 2 minus 1, I get negative 3. And again, I don't really care that that's a negative 3, I just care that that's negative. All right, and then keep moving through all of our intervals. I'm going to pick something between 0 and 8. 1 is usually easy to plug in. So cube root of 1 is 1, so this is 2 minus 1, which is 1. Again, I don't care that it's 1, I just care that it's a positive number. And then I'm going to pick a number to the right of 8. Now I'm actually going to pick 27. You could pick any number that you want, 9, 10, 11. I've just been taking cube roots of x in my derivative, and 27 is the next bit number after 8 that's easy to take the cube root of. So I'm just picking something easy. And cube root of 27 is 3, so this is 2/3 minus 1. Let's see, that doesn't look like a 3. 2/3 minus 1, which is a negative 1/3. Okay, so we get negative in that last region. And you'd get the same thing if you plugged in x equals 9, whatever you want to plug in. Anything bigger than 8. Okay, so then we know that a first derivative negative means the original function is decreasing. First derivative positive means f is increasing. And then negative means decreasing. And again, we're always talking left to right, decreasing, increasing, decreasing. All right, and so now I'm just going to write my answer. I'll come down here at the bottom and say f of x is decreasing on negative infinity to 0 and from 8 to infinity. It's hard to write 8 and infinity right next to each other. And then it is increasing on 0 to 8. Okay, so that's our increasing and our decreasing. All right, and then we want to also list the local mins and maxes. Right, so I'm going to erase all of my green work over here, my f prime work. And we're going to do the first derivative test. All right, and first derivative test told us if f of x goes from decreasing to increasing at a critical point, here at 0, decreasing to increasing means that we have a local minimum at x equals 0, and we're going to put a y coordinate in there in just a minute. And then at 8, left to right, before 8 we were increasing, and after 8 we are decreasing. So if you go from increasing to decreasing, you must have a local maximum. And that's at 8 comma something. All right, so then we're just going to figure out what those values are. I'm going to go plug into f of x. Remember, that's f of x, that original function over here, f of x. We're going to find f of 0, which is a bunch of 0. Okay, so the point 0, 0. And then I'm also going to find f of 8. 3 times 8 to the 2/3 minus 8. Okay, so 2/3, that's really 3 times the cube root of 8 squared. 8 squared is 64. Cube root of 64 is 4, so this is 3 times 4 minus 8. So 12 minus 8 is 4. Okay, so that's our first derivative test. Remember, the first derivative test tells us about local mins and maxes. All right, and then I'm going to head over to Desmos on my computer here, and I'm going to graph that function just so we can get some satisfaction in seeing what this thing looks like. So 3 times x to the 2/3 minus x. It's kind of a weird looking function here. Make that easier to see. Make it a little darker. Okay, and then here's our critical point that we had at 0, 0. All right, that's our local minimum, and you can see that's the critical point we got when the derivative was undefined. And then this point over here, 8 comma 4, that's our local maximum. That was the critical point we got when we set it equal to 0. And we can also see our decreasing before 0, increasing after 0, and then decreasing very slightly after we get to 8. All right, and there's our last example for section 4.5.